Okay, so we're going to look at examples 3 and 5 from lesson 5.5a, working with logarithms of other bases. And we're going to look at the reminder about the properties of logarithms. And here we have that the log base b of v is defined only when v is greater than 0. So the domain is all positive numbers. That b to the power of 0 is 1. So, and the log base b of b is equal to 1. So when the bases are the same, it equals 1. And number 3 here, that this is equal to k because the values of b are going to, are inverses of each other, so they'll offset and cancel. And the same thing happens here, right? So we're going to do example 3 where we solve this equation. Log base 3 of x minus 1 is equal to 4. And in solving this equation, we're just going to change it from logarithmic form to exponential form. So we're going to take the 3 and we're going to raise it to the power of 4. So 3 to the 4th power is 81. So we x minus 1 equals 81. So add 1 both sides and x equals 82. Okay? And don't forget always to check your answer. And so you would want to do that. So there's example 3. For example 5, we're going to review the laws of logarithms. Reminder about the product law, that we are multiplying. Here's the log base b of v times w is equal to the log base b of v plus the log base b of w. So there's the product rule. Reminder about the quotient rule here, that when we're dividing, we subtract. And then the power rule, which means I can take the exponent and move it to the front. So we're going to do example 5 here. Simplify this expression into a single logarithm. So the first thing we always want to do is whenever they're adding or there's a plus sign, always rewrite it. So in other words, what I mean is that if we had a situation where we had the log of x minus the log of y plus the log of z, that we would rewrite this as the log of x plus the log of z minus the log of y. And the reason we want to do that is so that we're doing the multiplication correctly, because using our properties, this would be the log of x times z, because of the adding, they multiply, divided by y. And so that's one of the things that you want to remember, is to do that. So anytime we have adding anywhere in this problem, we want to make sure that we put those together so that we have the correct multiplication. Right? In this problem here, the plus is first, so reminder that we multiply then when we're adding. So it's x plus 2 times y, and then minus the log base 3 of x squared minus 4. And then because of the minus sign, then that means we're going to divide. So we get the log base 3 of x plus 2, that quantity, times y, divided by x squared minus 4. And I'm going to go ahead and factor that, because now we're going to be able to do some canceling. We can cancel the x plus 2's, and we get log base 3 of y over x minus 2, because we were able to cancel these two out. So there's a simplifying, and here we're going to look at another example. Letter B here says 3 minus the log base 5 of 125x. Okay? So I can rewrite this, first of all, as 3 minus the log base 5 of 125. I want to do that because that's going to give me something I can simplify. And then I'm going to put parentheses here, plus the log base 5 of x. Right? Because that's, since I have the multiplication 125 times x, then I can have addition here. Notice that I put the parentheses in because this minus affects that whole quantity. Right? So I can simplify this. So we have 3 minus the log base 5 of 125 minus the log base 5 of x. And so we have 3 minus, and the log base 5 of 125. Well, 125 is 5 to the third power, so that's just equal to 3. So my final answer here is just going to be negative log base 5 of x. And so there is some of the demonstrations of lesson 5.5a, examples 3 and example 5.